Hello everyone, welcome you all to my YouTube channel. This channel is for physics of high school level students and mainly for ICC and some part based on CBSE. If till now you have not subscribed my channel, subscribe it soon to get the further notification. Click on the bell icon, and also if you feel this video is helpful for you, please click on the like button and give your valuable comment in the comment section. Every time I am coming near you with a new topic. Today I kept in this video for discussion is the topic measurement of length by using different instruments. So let us start from what is length, or we can say what is the basic definition of length. Then we'll come to different devices by which we will be able to measure the length. Here you can see one scale which is used to measure the length, and other instruments also used. So in this video we'll go with a different instrument used to find the length of a given object. That may be very thinner one or very broader one. So here if we'll come to the definition of length, here you can see the definition of length. Length is that measurement of distance, or we can say length is the distance between a path between any two points, one the initial point, one the final point, one the starting point, one the end point. So how much length, how much path, or how much far something covered is the length. Length having the SI unit meter, it is having some bigger unit like kilometer and some smaller unit like centimeter, millimeter. So here in this video we'll discuss about different instruments which are used to measure this length. We are used to measure the length of a given wall. So let's come to different instruments. First one, if we look here, meter rule or meter scale. In our geometry box we are using a scale starting from 0 cm to 15 cm. Sometimes we are using a scale which is starting with 0 cm and up to 30 cm. In Pasto, they are using a scale called meter scale. It is from 0 cm to 100 cm. We are using meter tab, and meter rule and meter tab is calibrated or having the measurement 0 cm, 1 cm, 2 cm, 3 cm, 4 cm like this. We continue. 0 to 1 cm, people look here. 0 to 1 cm, 1 to 2 cm, 2 to 3 cm, 3 to 4, all are divided into again 10 lines. Means each line value of a meter scale or centimeter scale is 1 by 10 of a cm or 1 mm. Means minimum we can measure 1 mm in a meter rule or meter scale. If we have to measure of object length or thickness less than 1 cm, then we are using another device that is called Vernier caliper. Vernier caliper can measure after decimal position, after decimal point 2 position in cm scale. Means if meter scale we can measure 5.1 or 5.2 or 5.3 or 6.9, but in Vernier scale we can measure the length between 5.1 and 5.2 or 5.3 and 5.4, 6.1 and 6.2. Then if we have to measure after decimal point 3 position in cm or after decimal point 2 position in mm, we are using another instrument for that, that is called screw gauge. Screw gauge can measure after decimal point 3 position in a cm scale, and in case of mm if we look, it will measure after decimal point 2 position. Means by using Vernier caliper and screw gauge, we can measure the very thinner object's length and their thickness. So here the term came the minimum how much you can measure by using any instrument. That's what we can say as the least count. The minimum measurement that can be measured accurately by any instrument is called the least count. Means least count of a centimeter scale is 1 mm or 0.1 cm. In Vernier caliper it is 0.1 mm or 0.01 cm. In case of screw gauge, it will come 0.01 mm or 0.001 cm. So when it comes to the first one here, you can see a Vernier caliper. Vernier caliper, which is also called slide caliper. This Vernier caliper or slide caliper having two scales. So in detail we'll discuss about this Vernier caliper or screw or slide caliper. This Vernier caliper is first time given by a mathematician Pierre Vernier. and by the motor, by the with the thinking, with the thought that to measure after decimal point 2 position in centimeter. So this vernier caliper actually having two scale. One is called main scale, just like our centimeter scale, the main scale, starting from 0 cm, it can go up to 15 cm. And one is the vernier scale, which is having some number of lines. So in the main scale, one division means one line value is 1 mm, like our centimeter scale, what you are using in geometry box. And vernier scale is having some number of lines. And how much the number of line in vernier scale, that always coincide means mix, or it comes straight with n minus 1 division in the main scale. Means if 10 lines given in the vernier scale, that is coincide with 9 lines of the main scale. If 15 lines given in the vernier scale, then it is coinciding with 14 lines of main scale. 20 lines given in the vernier scale, it is coinciding with 19 lines of main scale. So to calculate the least count of any given vernier caliper, which is also called a vernier constant, will use the formula that least count of vernier caliper equal to 1 main scale division by total number of division of vernier caliper or vernier scale. Means one main scale value is 1 mm and maximum vernier caliper having 10 lines in the vernier scale. That means 1 by 10 equal to 0.1 mm, or in cm if we look at 0.01 cm. Hence, least count of a vernier caliper is the distance or difference between one main scale division and one vernier scale division. Means of 10 line in the vernier scale coinciding with 9 line of the main scale. So least count is value of one main scale division versus 1 mm by total number of division of vernier scale, which is 10 line then 1 by 10, if 20 line then 1 by 20, 30 line then 1 by 30. We can calculate its LC or least count, or the smallest measurement that can be taken accurately by any vernier caliper. So if we'll come to different parts of this vernier caliper now, vernier caliper having different parts. In this part, all the parts are having different use. Here you can see one vernier caliper. First one, the outer jaw or upper jaw. This one is to measure the, first let to come to here, the lower jaw, this one. Lower jaw actually used to measure the length of a given object or rod or hollow cylinder or diameter of any given object. That may be a cap, a spherical object, or we can say a hollow cylinder or rod. This one, upper jaw, is used mainly to measure the internal diameter. Means if we are having a pen cap, inside part how much you can measure by using this upper jaw. This part is known as the fixed jaw, and this part is known as the movable jaw, because this part is movable part. It is the vernier scale part. So here we will get the vernier scale, which is movable with the help of a screw. By we are catching like this, that forefinger will catch the vernier caliper, and by the help of thumb will move the screw, because its vernier scale is sliding over the main scale. For that it is also known as slide caliper. And here you will get the main scale like your centimeter scale, and one more part at the last, that's called strip or depth rod, used to measure the depth of any given bottle or any hollow cylinder. So this is the different parts of any vernier caliper. So how to use this vernier caliper to measure the diameter or length of a given object. So if a measurement part here, you can see a vernier caliper. First thing, we'll place the object here between the fixed jaw and movable jaw. Then next thing, we have to look the zero mark. Zero mark of the vernier scale. Here you can see the zero mark of vernier scale. It is, and here it is the little bit magnified one. So zero mark of vernier scale will look, and this zero mark is after which line. Like here you can see after 2.1 in this diagram below, after after 2.1 you will have the zero mark of vernier scale. So that 2.1 is the main scale reading, this one. After 2.1 you will get the 0 mark of Vernier scale, that is 2.1 is known as main scale reading. Then from 0 to 10, 10 lines here, which line is coinciding means straight full. Which line of Vernier scale is straight with the main scale, that is called point of coincidence. Here in this if we look, sixth number 9 of Vernier scale is coinciding with the upper line. Other all if we look little bit left or right. Here also you can see it is some left or right. One line only will coincide. That is called point of coincidence. At that point of coincidence, when it is multiplied with LC or least count, we'll get Vernier scale reading or VSR. So to find the observed reading of a Vernier caliper, we are using main scale reading MSR plus LC into LC means least count into point of coincidence P, which is VSR. So MSR plus VSR will give us the observed reading. And all the Vernier caliper are having some error, that is called zero error. Error due to zero. Zero means zero we are having in the main scale, zero we are having in the Vernier scale. If zero of main scale and zero of Vernier scale will not coincide, means if zero of main scale and Vernier scale not remain straight, either it will remain left or right, any one side, then when both the jaws are together, when both the jaws are in contact, when both the jaws are fully closed, if zero of both the Vernier scale and main scale not coincide, that is zero error. If it is coinciding, then no zero error. And if it is not coinciding, then it will remain either left side or right side. So accordingly, we are having two type of zero error. One is called negative zero error, one is called positive zero error. If here you can see first one, if we look, 0 of Vernier scale and 0 of main scale both are coinciding. So this is free of zero error. But if we will come to this 0 mark, 0 of Vernier scale now, right of 0 of main scale. So if it is right, then we can say this one is the positive zero error. Then second one, if we look, 0 of Vernier scale is left of 0 of main scale. This is the 0 of main scale. Here the 0 of Vernier scale. 0 of Vernier scale, if it is left, then we can say it is at the negative zero error. So from our observed reading, we have to minus this zero error to get the correct reading. So to find the correct reading, we are having the Vernier caliper. We'll get two types of reading. One type of reading is called observed reading, and second type of reading is called the correct reading or true reading. So whenever we want to calculate true reading or correct reading, we have to take the help of zero error. So first thing or first formula here you can see is the about observed reading. Observed reading means when you come to the term observed reading is equal to MSR main scale reading or how much the main scale read during the measurement or before the zero mark of Vernier scale. What is the reading or how much the value of main scale? That's what you can say the main scale reading plus LC least count of Vernier caliper, which is we can calculate the LC by one main scale division by number of line or number of division in the Vernier scale. So into will get point of coincidence. Point of coincidence means the point or the line of Vernier scale which is coinciding with the main scale. So here we will get the observed reading, but if the instrument having any zero error, either that may be positive or negative, we can take true reading or correct reading equal to observed reading. How much we got, how much we observe, how much you have measure minus the zero error with the positive or negative sign, because the Vernier caliper either having a positive zero error or negative zero error. If it is having the zero error, then with the sign positive or negative, we'll subtract that zero error from the observed reading. It will come to a number to know how to use this formula, how to use this concept in a numerical problem. Then here you can see while measuring the length of a rod, main scale read 35 divisions. One main scale division, one main scale line, division means one line. One main scale line value is 1 mm because 0 to 1, 1 to 2, 2 to 3, this is divided again into 10 lines. That means one line value is 1 mm. So 35 lines, 35 mm plus fourth line is fourth division is coinciding with the main scale. So point of coincidence will get here 4. Zero error it is given to us minus 0.02. If the Vernier caliper having 10 lines in the Vernier scale, Then we can calculate its LC by taking 1 mm by 10, which is equal to 0.01. So here you can see the solution part. In solution, you will get MSR 35 mm, 35 lines, which is 3.5 cm, P4 LC 0.01 cm. If it is having 10 line in the vernier caliper or in the vernier scale, and object will equal to MSR plus P into LC, where P into LC is called VSR, vernier scale reading. So 3.5 plus 0.01 into 4, which is 3.5 plus 0.04 or 3.54 cm. But if we will come to the correct reading, we have to subtract the zero error from it. So 3.54 minus 0.02 or 3.54 plus 0.02, which is equal to 3.54 plus 0.02, that means 3.56. This is the answer of the question, you can say, or it is the length of the given rod, which one we are measuring by using this vernier caliper. So next instrument to discuss is the screw gauge. Because in the vernier caliper we got least count is 0.01 cm. Means after decimal we can measure two decimal. After the decimal point we can measure two positions in cm scale or centimeter scale. But if it will come the length between 1.22 and 1.23 or 5.29 and 5.30, how much it is to know we are using screw gauge to get more accurate. So screw gauge is having pitch. One more term used here, the pitch. Pitch means because the screw gauge we have to rotate from the last part, ratchet part. So pitch means how much maximum it will go after one rotation. That's what we can say as a pitch. Or because the screw is having number of thread, because whenever you are rotating to the ratchet part, the last part, so it will go forward. Then pitch means the distance between two thread or how much maximum distance the screw will go after one complete rotation. That's what we can say the pitch. And to find the least count, here we are having one more part that is called circular scale. Like in vernier caliper, we got vernier scale. Here we'll get one more part that is called circular scale. So pitch value or pitch of any screw gauge by total number of division of the circular scale. Most of the time pitch is 1 mm and total number of line in the circular scale is 100, then 1 by 100 equal to 0.01 mm. If it is 50, then 1 by 50 equal to 1 by 50 mm, or we can convert this one to cm. So because normally we are having 100 division or 100 line in the circular scale, so LC 1 mm by 100 equal to 0.01 mm or 0.001 cm. Now we'll come to different parts of the screw gauge. If we'll come to different parts of the screw gauge, first one you can see ratchet, the last part, the screw part. This one is used to rotate the screw, and here this gap will fill. When we rotate the screw, slowly this spindle part will move toward the stud or this part, anvil or stud. So when it will move, gradually this gap will fill, and depending upon the diameter of the object, will adjust with the help of this ratchet or the screw. Another one here you can see this part. Here it is the one line that is called baseline. This line is called baseline, and some lines are here, some numbers are here, that is called main scale of a screw gauge. And here you can see some number in a circular way, in a circle, that is called circular scale. And most of the time circular scale are having 100 reading or 100 lines. Some screw gauge having the 50 lines. And depending upon the circular scale division or lines, we are having the LC. So when this ratchet will rotate one time, then this screw will move by one line, that is 1 mm. So always for the pitch of a screw gauge is 1 mm, and most of the time number of division in the circular scale is 100. So 1 by 100 we are getting 0.01 mm or 0.001 cm, or we can measure up to decimal 3 position in the centimeter scale. So it will come to how to measure by using a screw gauge. Here you can see the stud, the gap. This one, when by the help of a ratchet, it will rotate, then this part will come slowly toward the stud part. This is the fixed one, this is a movable part. So this movable part will come toward the fixed part. And when it will completely tight, that sound will come, That sound shows that now it is completely tight. More if you rotate, then the sound will continue. It will give an error to your screw gauge. So here these two star going to join, then we can say this as the means both these are fully tight, then we can calculate zero error. And when we want to measure the diameter of any given object, any thinner object, we place the object here. Either you can place horizontally or vertically, and we'll by the help of this edge first will tight. After that sound will come, now it is tight, we'll look to this part. This is the baseline or is the main scale. In the main scale, how many lines will be visible to us? Now if we look here, if we'll keep any object of this much size, then how many lines are visible to us? 0, 1, 2, 3, 4, 5. Means here if it is 5, then it is 5 mm. So this how much part visible to us, how many lines visible to us, that what we can say the MSR, main scale reading. The next thing we'll look, this line, this baseline is straight to which number? Is 80, 82, 75, which number? That is called point of coincidence. That point of coincidence multiplied with LC will give us CSR, circular scale reading. So MSR plus CSR will able to know about the the observed reading. There are two type of zero error in a screw gauge. Like Vernier caliper having two type of zero error. In screw gauge also you'll get two type of zero error. First one, how to notice having zero error or not. If a screw gauge, if we look a screw gauge having two scale. One is called main scale or which is placed on the baseline. This is the baseline, and one scale is the circular scale which is in the circular head of the screw gauge. If the baseline is coinciding with the zero of circular scale, which is in the straight line, coinciding means fully straight. So that case there is no zero error. But if the zero is not coinciding, means zero of circular scale or above the baseline or down the baseline, accordingly we will get two type of zero error. First type of zero error, if the zero of circular head is down of baseline or below the baseline, that we can say the positive zero error. The zero mark is not coinciding any other line. Zero is not coinciding means here 1, 2, 3, 4 or any other line will coincide, then it's called positive zero error. But when you come to negative zero error, here you can see zero of circular head is above this baseline. So this is the negative zero error. If zero is above, that means some number which is 95, 96, 97 or 87, that type any number is coinciding with the baseline. In that case, when the number of line which is coinciding or number of division which is coinciding is more than 50 or more than half, that case, or in case of negative zero error, we can say we are taking 100 minus that number. Means here 96 number line is coinciding, means to find the zero error we will take 100 minus 96, which is 4. 4 into LC 0.01 in mm, so 0.04 mm is the zero error of this screw gauge. Means in screw gauge, if it is more than half or it is negative zero error, that case 100 minus that number. If total number of division is 100, if total number of division is 50, then 50 minus that number, because some screw gauge having 100 division, some are having 50 divisions. So depending upon the number of division, we can calculate its zero error. So zero error is of the instrument. So zero error you have to subtract from the object reading to get the correct reading, to get the correct data, or to get the true reading or true measurement of any given object. How to get the object reading and correct reading? Same way like the Vernier caliper, here also we'll get the formula object reading equal to MSR plus CSR, which is P into LC, and correct reading equal to object reading minus zero error. Zero error, that may be positive one or negative one. With the sign we'll write inside the bracket. Then it will come to a number here. While measuring the diameter of a hollow cylinder, main scale read 2 mm. 2 mm is MSR. 76 division of circular scale coincide the baseline, means 76 is the point of coincidence. And zero error also given to us positive one. So now let us come to the solution part. Here you can see MSR equal to 2 mm, P 76, LC 0.01 mm. Means now it will come to the CSR calculation, that 76 into 0.01, directly it will write observed reading equal to MSR 2 plus LC into point of coincidence P into LC. So this is 2.76 mm or 0.276 cm. Now it will come to the correct reading. 2.76 minus with the sign positive 0.34 plus into minus minus. So 2.76 minus 0.34, 2.42 mm is the correct reading of that given hollow cylinder. So by the help of screw gauge and vernier caliper, we can calculate the length and diameter of any thinner object. But people use the screw gauge and in a screw gauge. Now we can calculate the CSR, we can calculate the length and diameter of a very thinner object. So two ways by which we can increase the least count of any screw gauge. Least count we having the formula pitch by number of division in the circular scale. Least count means how much minimum it can measure. So least count we can increase first thing by decreasing its pitch, which is 1 mm. If we are able to decrease 0.7, 0.6 or 0.5 that time, or by increasing the total number of division on the circle. In this we got sometime it is 100, sometime it is 50. If we are able to increase to 500, 1000, then also we can increase the least count. Means less it can measure, so least count can be more. And in the screw gauge we got the ratchet is used to rotate. So any one direction either in clockwise or anti-clockwise you can rotate. If we will rotate clockwise, anti-clockwise more often, then gradually the thread inside will tear and the ratchet will slip over it. That is called backlash error, and because of which the measurement will fail for that reason. When you are using any screw gauge, first thing either will rotate this one in clockwise direction or anti-clockwise direction, and up to that will rotate when the tick sound will come. Once the sound came means it is tight. No need to rotate more. It will rotate more when the thread will steer, and after that that ratchet will slip and will not able to get its correct reading. So this is about the screw gauge and vernier caliper. And we know the use of cm scale or meter scale to measure the length. So this is all about the length. So to get more videos, like my videos if you feel it is helpful for you, and subscribe my channel and click on the bell icon. Thanks.